Welcome to the Explainer. Okay, so we're diving right into how we monitor the health of our planet from the stars. Now, we've all seen basic satellite images of Earth, right? But today, we're looking at a specific, massive technological leap that is literally changing the game for environmental science, urban planning, and climate tracking.
And what's really fascinating about tracking the Earth from 700 kilometers up is that solving urgent problems, think sudden deforestation, expanding cities, or toxic algal blooms, requires near real-time data. I mean, if a forest is being illegally logged, finding out about it a month later doesn't help anyone, right? We need continuous, highly detailed updates. And that brings us to a revolutionary technology that's quite literally watching over us right now.
So, here's our flight plan for today's Explainer. First, we'll meet Sentinel-2. Then check out its high-tech eyes in space. After that, we're putting it head-to-head against Landsat, exploring how it monitors Earth's vital signs. And finishing up with the ultimate space team-up. Let's get into it.
Section 1. Meet Sentinel-2, the Copernicus program's twin guardians. So Sentinel-2 is this incredible high-resolution, multispectral imaging mission funded by the EU and the European Space Agency. And what's cool is it's not just one satellite, it's actually twin guardians, Sentinel-2A and 2B, working in tandem to monitor absolutely everything, from dense vegetation and soil health to coastal areas and inland waterways.
Moving to Section 2, High-Tech Eyes in Space, Unlocking the Satellite's Superpowers. Let's break down how this specific satellite acts kind of like a giant, highly detailed MRI for the Earth, because it doesn't just snap pictures, it captures data across a massive, invisible spectrum.
And this perfectly illustrates the multispectral instrument on board the Sentinel satellites. It measures reflected radiance across 13 distinct bands, which gives us a view way beyond human sight. From coastal aerosol bands all the way out to shortwave infrared, Sentinel-2 is pulling in this dizzying array of data that helps scientists essentially peel back the layers of what's happening on the ground.
Now, the really crucial point here is that Sentinel-2 features 3 of these totally unique red edge bands. Because this specific zone of the electromagnetic spectrum is incredibly sensitive to chlorophyll content, it makes Sentinel-2 an absolute powerhouse for estimating plant health. It basically lets us see how well plants are breathing and photosynthesizing entirely from space.
But you know, it's not just about the type of light it sees, it's about the crazy level of detail. To put this in perspective, traditional moderate-resolution satellites capture imagery at about 30 meters per pixel, right? That's roughly the size of a baseball diamond. Sentinel-2's visible and near-infrared bands operate at a 10-meter resolution. So if 30 meters is the whole diamond, Sentinel-2's 10-meter resolution lets us clearly see the individual players standing inside it. And here is where it gets even better. By operating those twin satellites on opposing orbits, Sentinel-2 pulls off a lightning-fast global revisit time of just 5 days. Every 5 days, we get a fresh, high-resolution scan of the exact same spot on Earth. That is absolutely perfect for catching super sudden environmental shifts, like an outbreak of wildfires or rapid crop changes.
All right, Section 3, Sentinel-2 versus Landsat, the moderate resolution showdown. Let's see what happens when we compare Sentinel-2 to the legendary Landsat 8 mission. Landsat is this incredible, historic NASA program for sure, but when it comes to near real-time, high-detail monitoring, how do they stack up head-to-head?
Well, in a direct land cover classification study focused on rapid urbanization in Kabul, researchers really needed to accurately map the boundaries between expanding urban zones, croplands, and water. And honestly, Sentinel-2 completely outshone Landsat here. With its higher spatial resolution, Sentinel-2 precisely nailed those boundaries. Landsat 8 actually suffered from misleading classifications. And get this, it missed entire sections of the Kabul River, mistaking them for urban or agricultural land because the pixels were just too mixed.
Specifically, in that Kabul study, Sentinel-2 achieved a massive 94.26% overall accuracy compared to Landsat's 85.04%. Now, when city planners are relying on this data to protect croplands and manage vital water resources, that 9% gap in accuracy, it's literally a game changer.
Plus, check out this comparison from a community forest study in Nepal where scientists were trying to estimate above-ground biomass. Sentinel-2 produced a vastly superior correlation model, hitting an R-squared of 0.76 with a much lower prediction error than Landsat 8. Once again, those red edge bands and that crisp resolution give Sentinel-2 a massive winning edge in forestry.
Okay, Section 4, Monitoring Earth's Vital Signs, bringing the data down to Earth. Let's dive into how these incredibly accurate numbers actually help us track the planet in real time. Like, how are we using this massive stream of orbital data to make a tangible difference on the ground?
Well, it starts with indices like NDVI, the Normalized Difference Vegetation Index. By taking a mathematical ratio of the near-infrared and red bands, scientists can instantly compute exactly how dense and healthy a forest is. It allows us to accurately measure carbon storage across these vast, completely inaccessible landscapes, right from orbit.
Just look at this incredibly vibrant map of the Salbot Kareli forest in Nepal, generated using Sentinel-2's NDVI data. The deep green areas highlight dense biomass, while the red areas show lower density. These maps represent critical carbon sinks. And proving exactly how much carbon a forest holds is absolutely essential for global climate mitigation programs like REDD+, which actually offer financial incentives to countries to protect their forests and keep that carbon locked away.
But it goes way, way beyond just forests. From spotting toxic microsystems in California's Lake Elsinore using the Cyano Tracker early warning system, to mapping soil salinity, to assessing burn severity right after massive wildfires, these applications prove Sentinel-2 is an unbelievably versatile planetary guardian.
Finally, Section 5, the ultimate space team-up, harmonized Landsat and Sentinel-2. Because think about it. Instead of keeping a rivalry going between Sentinel-2 and Landsat, what if NASA and ESA united their satellite fleets into this giant Avengers-style team-up? What happens if we combine the rich, historical archive of Landsat with the rapid, high-resolution capabilities of Sentinel-2? Watch closely as this builds, because it's super fascinating. This is what 24 hours of Earth coverage looks like using just Landsat 8. Notice those massive black gaps across the globe? Because it operates alone on a 16-day repeat cycle, as the Earth spins beneath it, huge swaths of the planet are just left completely unseen on any given day.
Now we add Sentinel-2A into the mix, harmonizing the data to an unprecedented 30-meter standard so the different datasets can talk to each other seamlessly. And you can see, the gaps are rapidly starting to close.
Toss Sentinel-2B into this harmonized framework, and our planetary vision becomes immensely clearer. Those vast black gaps of missing data are shrinking by the minute, filling in all our blind spots across the continents and oceans.
And finally, combining the full forces of Landsat 8 and the newer Landsat 9 with the growing Sentinel-2 fleet, boom, we get a nearly complete daily picture of the Earth's surface. By aligning these systems to act as a single massive collection, scientists don't have to choose between datasets anymore. They literally get the best of both worlds.
This ultimate space team-up drops the repeat observation period from 16 days down to a staggering 1.6 days. We are essentially looking at a continuous, high-definition live stream of the Earth's changing surface.
With humanity now watching our planet's health almost live, we have the actual tools to stop illegal logging in its tracks or warn communities of toxic water days before they drink it. If we can now see environmental destruction happening in near real time, the true challenge is no longer gathering the data, it's how quickly we act on it. So what environmental mysteries will we solve next? Keep exploring, keep questioning, and I'll catch you next time on The Explainer.